See Standard 10th Maths Chapter 7 Mensuration Exercise 7.2. For sum, a 14-meter deep well with inner diameter 10 meter is dug and the earth taken out is evenly spread all around the well to form an embankment of width 5 meter. Find the height of the embankment. See, before start doing the problem, let us discuss about the volume of the cylinder and volume of the hollow cylinder. See, when I take the volume of the cylinder, the volume of the cylinder depends upon the area of the base. So base area is the circle, pi r squared, and also it depends on the height. If the base area is bigger and the height, you will get the bigger shape. It may be the drum also. See this cylinder, it is narrow. So in that case, the area of the circle is smaller one, and we have the height also. It may be greater or lesser also. So when I take the volume of the cylinder, it depends upon the area of the circle, that is pi r squared, and height of the cylinder, pi r squared h. So V is equal to pi r squared h. So here 3 units we discuss, r squared, 2r and 1h, altogether 3 units. So you will get cubic units. So volume of the cylinder is pi r squared h cubic units. Next you see the volume of the hollow cylinder. See, the volume of the hollow cylinder is here. Hollow means the interior part is empty. So in that case, you will get some thickness also. So volume of the outer circle and also outer circle. If I get the outer cylinder, volume of the outer cylinder, I take that R as capital R. So pi r squared h, capital pi r squared h. H is same for both outer cylinder and inner cylinder. I subtract the volume of this inner cylinder. Inside you will get the hollow cylinder. So pi small r squared h. So take pi as common and h also common. So inside the bracket you will get r squared minus small r squared h. So pi bracket capital R squared minus small r squared h. Again this is also cubic units. When you take volume you will get 3 units. So cubic units. So only 2 formulas only you are going to use in this volume part. So volume of the cylinder is pi r squared h. Volume of the hollow cylinder is pi into capital R squared minus small r squared h cubic units. Now let us come to the problem. The well 14 meter deep, that is height of the well is 14 meter with inner diameter. So inner diameter is, we have 2 diameters they mentioned, because well is also just like hollow cylinder only. So interior will get 1 cylinder, outer part 1 cylinder will get. So inner diameter is 10 meter is dug and the earth taken out is spread all around the well to form an embankment of width 5 meter. Actually embankment is the wall around the well. So well, inside the well you will get the hollow one, so you will get the water also, but around that you are getting the wall. So that is the hollow cylinder. So here they given the height of the cylinder h. You take hollow cylinder. So height of the cylinder h is equal to, they given as 14 meter, and the inner diameter they mentioned, inner diameter small d is equal to, they given as 10 meter. So radius, inner radius is equal to small r is equal to half of this 5 meters. See, all the units are in meter. Okay. And then see, again they given the width of this embankment. The wall around this well is thickness is 5. So W is equal to 5. W is equal to 5 meter. 5 meter. So what about capital R? Capital R is equal to small r plus W. Small r plus W. So 5 plus 5 is equal to 10 meter you got. Okay, now look at the question. So we take out all the sand inside this well and we form the embankment, that is wall around the well. Find the height of the embankment, height of the hollow cylinder. Find the height of the hollow cylinder. So how do you get the well? So we take out all the sand from the inner circle and we form this hollow cylinder. So therefore the volume of the inner cylinder is equal to, see, we take out all the sand from this well, that is we all the sand from the inner cylinder and we form the wall around the well, that is the hollow cylinder. So volume of the cylinder, that is also inner cylinder, that is very important, inner cylinder is equal to volume of the hollow cylinder. Volume of the hollow cylinder. Inner cylinder is small r. So pi r squared h is equal to hollow cylinder pi capital R squared minus small r squared into, see here the question is they are asking you to find the height of the embankment. So to differentiate this, the height is not same. Let me make the height as capital H, because they given the volume. Height of this cylinder is also 14 meter, but the height of this embankment is different. So keep pi as it is. What is r, small r here? Small r is 5 into 5 and height they given as 14. So pi, what you have got, capital R 10. 10 square minus 5 squared. So capital H, this height I have to find. This is the height of the wall around the well, the height of the embankment. So pi into 5 into 14 is equal to, you do the calculation of this, 10 squared is 100. 100 minus 5 squared, 25. So that is 75 into H. I have to get capital H. So I bring these two numbers to the left side. Pi into 5 into 14 divided by pi into 75. So pi gets cancelled. 5 here it goes, 1 5s are 5, 1 5s are 5, 5, 15, then 3 5s are 15. So 14 by 3 is our H. So 3 3s are 9, 4 3s are 12, then remainder 2 carry over, 6 3s are 18, then 2 7, 4.67 meter. Our H, capital H is equal to 4.67 meter. That is height of the wall around the well. That is height of the embankment. Embankment is the wall around the well. is equal to 4.67 meter. See the second question. A cylindrical glass with the diameter 20 centimeter has water to a height of 9 centimeter. So a cylindrical glass with the diameter 20 centimeter has water to a height of 9 centimeter. A small cylindrical metal of radius 5 centimeter and height 4 centimeter is immersed completely into the glass. Calculate the rise of water in the glass. See here, the glass is the bigger cylinder. You have the water inside the glass. So it's a bigger cylinder. We have the small cylindrical metal, solid metal, small cylinder. So just I dipped into this water. I dipped this small cylinder into the glass of water, so that the level of water raised in the cylindrical glass. So the raised water level depends upon the high weight of the, that is volume of the metal cylinder. The question is, find the rise of the water in the glass. How much water level is raised here? So let me take the two cylinder. One is bigger one and the other one metal cylinder is smaller one. I take that as the smaller one. So bigger cylinder. Bigger cylinder. Take capital R. Take this as capital R and capital H. So how much they given capital R here? The diameter is given with the diameter. So capital D. So capital D is equal to here 20 centimeter. Units are in centimeter. This is very important. So capital R is equal to half of this 10 centimeter. And the height they given us 9 centimeter. You keep this as. Then smaller cylinder. Smaller cylinder. Smaller cylinder. Radius and the height. So smaller cylinder radius is given as here 5 centimeter. Height is 4 centimeter. Okay. See here the question, find the height of this water level raised here. Let me mark this as H1. Up to this you have capital H, and to differentiate with this height of the smaller cylinder I mark this as H1. But I want to find this height H1 only. So I write volume of the water raised. Volume of the water raised is equal to volume of the metal cylinder, small cylinder. Volume of the metal cylinder. So volume of the water raised is pi, and this is the radius of the glass, capital R squared. Water raised is small h1 I marked. So h1. Okay, we no need to use this capital H. Just mark this as h1. Volume of the metal cylinder is pi small square h. Just write cubic units. Okay. So just keep pi as it is. What about here capital R? Capital R is 10. 10 into 10 into h1 is equal to pi. Small r is here 5. 5 into 5 into h is 4. 4. So h1 I have to find. h1 is pi into 5 into 5 into 4 divided by pi into 10 into 10. 5 here it goes 2 times. 2 times pi. Both the 2's cancel. So h1 is 1 centimeter. So the rise of water level in the cylindrical glass is 1 meter. That is, the rise of water level H1 is 1 centimeter. Thank you.